Today we will be applying what we have learned so far about linear systems. The first method we used was graphing, and because it's not very accurate if you do it by hand, you'll only want to use graphing if you can use a graphing calculator. Substitution is easiest to use if there's one variable already by itself, and elimination would be a good method to choose if the terms are aligned or if they have a common term. So if you're trying to figure out which method to use, that is how I would determine which method I would use to solve it. Example 1 in our application part today says a metal worker has some pieces of metal alloy that are 20% copper and others that are 60% copper. How many kilograms of each type should the metal worker combine to create 80 grams of a 52% copper alloy? The first thing I would suggest you do is figure out what the variables are going to stand for. In this case, I'm going to have X stand for the mass of the 20% alloy, and Y stand for the mass of the 60% alloy. Okay, now I can go ahead and I can write our equation. It says how many kilograms of each type should the metal work to combine to create 80 kilograms. So together their masses are going to be 80 kilograms. So X plus Y has to give me a mass of 80. The second part there says I want it to have 52% copper alloy. So remember, X is my 20% plus my 60% is going to give me 52% of the total. Remember, the total was 80. So I need to simplify this second equation before I can start. So it would be 0.2x plus 0.6y is equal to 41.6. So that is that one rewritten. So now I have my two equations and I need to solve it. It doesn't tell me which method I have to use in order to solve it, so I'm just going to go ahead and I want to use substitution here. So I'm going to get X by itself. So I'm going to say X is equal to 80 minus Y. And I'm going to sub that in for X. So when I sub that in for X, it looks like the following. 0.2 times X, which is 80 minus Y, plus 0.6Y equals 41.6. And now I go ahead and solve this for Y. I have 16 minus 0.2Y plus 0.6Y equals 41.6. Negative 0.2 plus 0.6y gives me 0.4y. 41.6 minus 16 gives me 25.6. And now I'm going to divide both sides by 0.4 and I get y equals 64. I'm going to take that and substitute that in right here. And I have x equals 80 minus 64. So x is going to equal 16. I'm going to write my answer in statement form. To make 80 kilograms of 52% copper alloy, you need 64 kilograms of 60% alloy and 16 kilograms of 20% alloy. And there's my statement. And I have a typo there. There we go. So to make 80 kilograms of 52% alloy, you need 64 kilograms of 60% alloy, because I need 64 of y, and 16 kilograms of 20% alloy because x is equal to 16. So it's going to be much easier if you clarify what your variables stand for before you start. Another real life example would be a break-even point. So when starting a business, people want to know the break-even point, the point at which their income equals their expenses. The graph at the right shows the break-even point for one business. So if I look here, my income is the blue, that's the money coming in. The pink is the expenses. Okay, obviously to start a business, I had to start with some expenses. And then the income eventually catches up to where my expenses are, hopefully, if we have a good business going, and the income passes our expenses, and that's when we start to make money. So notice that the values of y on the red line represent dollars spent on expenses, and the values of y on the blue line represent dollars received as income. So y is used to represent both expenses and income. Okay, so our real life one using expenses and income says, suppose a model airplane club publishes a newsletter. Expenses are 90 cents for printing and mailing each copy, plus $600 total for research and writing. The price of the newsletter is $1.50 per copy. How many copies of the newsletter must the club sell to break even? X, I'm going to say, are the number of copies they have to sell, and y is the money. It's either going to be income or expenses. It'll be both of them. Okay, so then we're going to write our two equations. I'm going to let the first one represent income and the second one represent the expenses. So it says the price of the newsletter is $1.50 per copy. So each copy I sell, I make $1.50. So there's my income. And for my expenses, I have y is equal to 90 cents for each copy plus 600 total. So there are my two equations that I need to solve. Since y is already by itself, I'm going to use substitution. I'm going to sub that in for y right there. So I'm going to have 1.5x is equal to 0.9x plus 600. I'm going to get my x's together, so I'm going to subtract 0.9x, so I get 0.6x equals 600. Divide by 0.6, and I get x equals 1,000. The question here just asked, how many copies of the newsletter must the club sell? So all I needed to figure out was the x. I did that, so now I can write my statement. To break even, they must sell 1,000 copies. Anything over that, they start making money. Turn the page to get to our next example. This is actually the last example for this lesson. In lesson 3.6, you modeled rate, time, and distance problems using one variable. You can also model rate, time, distance problem using two variables. The steady west to east winds across the United States act as a tailwind for planes traveling from west to east. So when you're going from west to east, the air helps push you along and moves you faster. The opposite happens when you go from east to west. So the following says, suppose you fly from Miami, Florida to San Francisco, California. So from Florida to California, the winds are going against you, so it would slow it down. At the same time, your friend flies from San Francisco to Miami. So she's going the same distance, but this time the wind is helping her to get there. Her plane travels at the same average airspeed, but her flight only takes 5.2 hours. So it shortens it because it makes the plane go faster. Find the average airspeed of the plane. Find the average wind speed. So again, I would look at our two things here. For the first one going from west to east, we have the air speed plus the wind speed gives you our ground speed. And the one that's going from east to west, we have the airspeed minus the wind speed, because it's working against them, is equal to speed. So we know from last time that distance is equal to rate times time. Okay, well, speed that we have on both of these, speed is going to be your rate. So for both of our next equations, we will substitute in a minus w or a plus w for your rate, because that is making up your rate. So if we go over here, we have distance is equal to the rate, which is a plus w, times the time. On the other side, we have distance is equal to the airspeed minus the wind speed times the time as well. And now I'm going to fill in the information we know. Well, we know that both of them are traveling the same distance of 2,600 miles. We don't know the air or the wind speed, but we do know that this one would be the time is going to be 6.5 hours. And over here, the air minus the wind is going to be times 5.2. And I believe I have those signs mixed up, so let me fix that. The air plus the wind, if the wind's helping them, that means they will travel faster. And that one over here should be minus. Okay, so then, if I go ahead and I simplify this out, we have a minus w is equal to 2,600 divided by 6.5, which is 400. And over here we have a plus w is equal to 2,600 divided by 5.2, which gives me 500. And now I can have my system here. A minus w equals 400, and a plus w equals 500. I am going to use elimination. I'm going to choose to add, so a plus a gives me 2a. The w's cancel out, is equal to 900. I'm going to divide both sides by 2. So I get a is equal to 450. I'm then going to sub that into one of the equations. It doesn't matter which one. Let's say I sub it into this one over here. And I would get a is what we already have. 450 minus w equals 400. I'd get negative w is equal to negative 50. So w equals 50. I have a and w both solved for, so now I can write my statement. The average airspeed is 450 miles per hour, and the average wind speed is 50 miles per hour. Now you can go ahead and complete your quick checks, and then look at the schedule for your assignment that goes with this section.